Assalamu alaikum everyone. I am Mohammed Islam Simon. My ID is 20210208 on 42. Today I am going to share with you a presentation on the paper titled Analytical Investigation of Green Composite Lamina Utilizing Natural Fiber to Strengthen PLA. To begin with, this research focus on creating eco-friendly composites material by reinforcing and biodegradable polymer known as PLA with natural fibers such as bamboo, flax, and jute. The main goal is to understand how fiber orientation angle and fiber volume fractions influence important engineering properties like Young's modulus, shear modulus, Poisson ratio, and shear coupling coefficient. Green composites are increasingly popular because they are sustainable, renewable, and biodegradable, and they are offering an environmental friendly alternative to traditional synthetic composite. However, they still face some challenges, including moisture absorption and weak bonding between fiber and matrix. This paper uses an analytical approach to investigate how these challenges can be overcome through careful selection of fiber and orientation. Now, moving on the section about fiber anatomy properties, natural fibers have a unique internal structure with several layers and a hollow core known as the lumen, which if affect their mechanical performance. The study focuses on three types of fiber: bamboo, flax, and jute. Bamboo fibers are known for their excellent strength, stiffness, and fast growth, making them highly sustainable and effective as reinforced material. Flax fibers are also strong, flexible, with high stiffness and tensile strength, and are widely used in industry like textile and aerospace. Jute fiber, although less strong than bamboo and flax, are low cost and biodegradable and still used for application like packaging and construction. Next, I will explain the macromechanical approach used in this study. A lamina is a thin layer of fiber reinforced composite, and its mechanical behavior is highly dependent on the orientation of the fibers. In this analysis, the lamina is considered homogeneous and follows linear elastic behavior under plane stress condition. The main engineering constant studied are the longitudinal and transverse Young modulus, the shear modulus, Poisson ratio, shear coupling coefficient. Fiber orientation plays a key role in determining these properties. When fibers are aligned parallel to the load direction, Young modulus is highest, while EY become dominate at 90 degree when fibers are perpendicular to the load. The shear modulus reaches its peaks near 45 degree, and similar variation are observed for Poisson ratio and shear coupling coefficient. These show how mechanical performance can be tailored by adjusting fiber orientation and volume fraction. There are some formula about Young's modulus, shear modulus, Poisson ratio, and shear coupling coefficient. Now, let us now look at the key findings of the research paper, and here's the result. The result indicate the Young modulus EX is maximum when the fiber orientation is 0 degree and minimum at 90 degree, whereas EY shows the option 10 trend. The shear modulus increases with fiber volume and reaches its peak around 45 degrees. Poisson ratio and shear coupling coefficient also increases with orientation, peak at certain angle, then decrease. Among the three composite bamboo, PLA consistently demonstrate the best mechanical property, particularly in terms of shear modulus and shear coupling coefficient. PLA flex PLA shows a higher Poisson ratio and balance stiffness, while jute and PLA, though mechanically weaker, remain valuable for its cost effectiveness and biodegradability. These findings confirm that both fiber type and orientation significantly affect composite performance, with bamboo emergingly in the most effective reinforcement material overall. Finally, I will summarize the discussion and conclusion of this study. The paper concludes that fiber orientation and volume fraction are crucial factors in determining the mechanical performance of natural fiber composite bamboo PLA laminate perform the best across most properties, especially at lower fiber orientation angles, making them ideal for structural application requiring high strength and stiffness. The research also provide important guidelines for designing hybrid composites and optimizing fiber constant and orientation to achieve desired engineering properties. Although the study is theoretical and requires experimental validation, it offers valuable insights into how natural fibers, especially bamboo, can significantly enhance the mechanical behavior of PLA-based composite. In conclusion, this research highlights the potential of natural fiber reinforced green composites as sustainable, high-performance materials for future engineering applications. The paper, the research paper analytical investigation of green composite lamina utilizing natural fiber to PLA is strongly related to the composite material course, as both are grounded in macromechanics of lamina in mechanical ME 4037 course. A lamina is treated under plane stress conditions, simplifying three-dimensional stress-strain relationships, two-dimensional form, and its mechanical behavior is described using K constant, longitudinal and transverse Young modulus in plane, shear modulus, and Poisson ratios. This constant provide a foundation for predicting how a unidirectional laminars respond to tension, compression, and shear stress. Overall, the paper translates the analytical macromechanics theory from our course into a practical study, predicting the mechanical performance to eco-friendly green composite by showing the bamboo PLA laminars offer superior stiffness and strength. It highlights how macromechanics can guide the design and optimization of sustainable composite material effectively, bridging academic theory with real-world engineering application. That's all from my side. Thank you, everyone.